Let's evaluate this integral. Now this one is interesting and it looks a little complicated, but we could start by dissecting it. So in my numerator I have an exponent squared, and then in my denominator I have something that kind of resembles a quadratic. I have an exponent squared plus an exponent plus a constant. So what happens if I had, instead of an exponent, I had a variable? Luckily, I can do that. I could do a substitution here. With my numerator, I can rewrite it as e to the x times e to the x. So then I already have my dx in there. So I could say my u is equal to the exponent e to the x, and then du would be equal to also e to the x dx. And now if I rewrite my integral in terms of u, it's just u over u squared plus 3u plus 2 du. Now this integral looks a little more familiar to us. I noticed that I have a function that I can factor in the denominator. It's a quadratic. So if I factor it, it's u over u plus 1 times u plus 2. And now I could start decomposing this. So this turns into a partial fractions decomposition integral. So now I will be giving two arbitrary constants. I'll have a over u plus 1 plus an arbitrary constant b over u plus 2. And to find these two constants, a and b, I'm going to start by doing a cross multiplication situation so that I have this in one condensed fraction. So I'll have a times u plus 2 plus b times u plus 1 all over u plus 1 times u plus 2. And now if I distribute, just ignoring the denominator for a second because we don't really care, distributing the terms in the numerator, I have au plus a2 plus bu plus b, all equal to my original numerator over here, which is just u. And now from this expression, I can create my system of equations. And how I like to create my system of equations is kind of playing a game of matching. So I look at my terms on the left-hand side that are attached to my variable, in this case u, and equate it to whatever's attached to a u on my right-hand side. And anything that's attached to a constant on the left-hand side, I equate it to whatever is attached to a constant or is a constant on the right-hand side. So my u terms, I have au, bu, and u. So my first equation is going to be a plus b is equal to 1. And then for my constants, I have a2 and b, and I have nothing in my right-hand side, so it's just 2a, I guess a2a plus b is equal to 0. And now you can solve your systems of equations however way you would like. There are many ways to solve systems of equations, believe it or not. If you know, you know. But I can start by looking at that second equation, and immediately I can define b is equal to negative 2a, and I can immediately plug that into the first equation to give me negative a is equal to 1, or a is equal to negative 1. And now that I have a, I can very quickly plug it into the second equation and get b, or the first equation, does not matter. Either way, you'll find that b is equal to 2. Now that I found my two arbitrary constants, I can go back to my decomposed integral and actually start integrating. So I had a over u plus 1, and I just said that a is negative 1, so negative 1 over u plus 1 du plus the second integral. And you could integrate them all at once, or you can split them up the way I'm doing. It does not matter as long as you get the same answer. So b is 2 over u plus 2 du. And this is pretty easy to integrate because it's just going to end up being a log. So the first integral over here, it's going to be negative natural log of u plus 1. And then the second integral gives me 2 natural log of u plus 2 plus an arbitrary constant c because this was an indefinite integral. Now you think that we're done, but we are not quite yet. Remember that our original integral was in terms of x, and we had a substitution situation going on. We defined u as the exponent, e to the x, so I have to put that back in. So negative ln e to the x plus 1 plus 2 natural log of e to the x plus 2 plus the arbitrary constant c. Now this is a good enough answer, but I want to go the extra step and write everything in as simplified as a form as I could get. So using my log rules, I know that I could take this 2 and make it an exponent here, so I'll have negative ln e to the x plus 1 plus ln e to the x plus 2, so this whole thing is squared, and then using another plus e, and then using my other log rule, I can make this into a fraction because I have a negative over here, so it's like I'm subtracting the 2, so then this term goes on top, so this becomes the natural log of e to the x plus 2 squared over e to the x plus 1 plus the arbitrary constant c. And that's it.